So firstly, why is, why is climate so hard to deal with? Well, it's this thing called a hyperobject that Timothy Morton came up with. Basically, we only see a tiny part of anything that happens as a result of it, and we can't really relate to it or understand it very easily based on those impacts. Happens over a really long time period. It has a long lag time, so obviously actions we take now have a long time to pay back or even to cause problems for us in the future over years, decades, and often centuries as well. And it affects everything that we do. So that makes it it's good in a way because it means that everyone has some sort of reason to act upon climate change or to make their lives better in addressing climate change. And it's either direct through like the direct impacts of weather and extreme events, or indirectly through the economic impacts and the societal impacts that we have through that. One of the really biggest problems about it, though, is that it's caused by everything we do as well. So basically, we're all bad, and that's really, really bad for politicians and policy, and makes it a very difficult situation to deal with. But the other thing as well is that we've left it too late. We could have done this pretty painlessly and actually in a way that was just a wholesale benefit for society. But the fact is we've left it so late, so we can't really do it easily and cheaply in the short term. With regards to trying to understand it, well, the Stockholm Resilience Centre, they came up with this idea, and Johan Rockström of that institute as well did his documentary about planetary boundaries to try and describe how wide-ranging the impacts are on different parts of the global ecosystem. But then we've got to come up with this idea of how do we research and communicate, act on this, through this really expansive issue that affects everything we do and everything we see. So it's got effects on land, ocean, atmosphere, and the cryosphere, the frozen environment, like the polar bear earlier. And also we're introducing novel entities or new substances into nature that it hasn't been exposed to before. So we don't really know, for example, how plastics are really interacting with nature as of yet. There's still a lot to be discovered on that front. Also, as it changes, we change. We change in how we respond to it, how we act, and also as we change, climate changes in response to that as well, as we've already been finding with the drivers that we're forcing on the climate system by carbon pollution and environmental degradation. So it's incredibly complex, and these are the reasons why it's so hard to tackle. And there's a really great we've got links on our website to all sorts of resources, but there's a really great documentary about the planetary boundaries on Netflix if you get a chance to watch that. There's links all through the slides, by the way, so I'll share this afterwards and you can click through these things at your leisure. Yeah, it's just there's so many great resources out there. It'd be a shame to just leave it here in the presentation. So basically, the way we try to describe this absolutely massive and unwieldy problem is through our IPCC reports, and they really are the best way of understanding this. We've got Working Group 1, which is the physical science, Working Group 2, which are the impacts, and then you've got Working Group 3, which focuses on the solutions and how we stop climate change or slow it and how we adapt to it. In the last report, there were 748 academics writing the report. They cited 66,000 papers, and they had to respond to almost 200,000 comments. And uncertainty is something that's baked into, obviously, science and science communication these days, and that does make it difficult. But regardless of how much we've researched and how much we know, there's still a lot that we don't know, and especially in areas to do with biodiversity. So there was a talk that I attended recently from the Civil Service Environment Network. We had a Working Group 2 lead author talking about the marine environment and saying that there's a huge amount of uncertainty about what's happening in the marine environment, and also where climate tipping points are in the marine environment. We know that they exist, but we don't know what temperature thresholds they're actually going to tip. So there's obviously links to that presentation here as well. But so the way we try and explain it is through these things called shared socioeconomic pathways. These are different trajectories that we would take, and the big ones is 1, 2, and 5. And SSP1 is like the best one. That's us staying under 1.5, doing everything we can. No dangerous warming above 1.5 degrees. Crisis averted. And then there's SSP2, which is the middle of the road. That's what we're on at the moment. Climate policy, decarbonisation, that stuff that's already happening. And then we've got SSP3 and 4. These are ones where humanity kind of it doesn't turn on itself, but it becomes very unhelpful to itself. Globalization starts to fall apart. In SSP3 and in SSP4, you end up having, or in pathway 4, you end up with, a few wealthy countries who are doing okay, and then the rest of the world is really suffering. But then this is a really important one to remember, is SSP5. This is the fossil fuel development side of things. And SSP5 basically means that what we do is we do everything actually quite well. You know, we take care of education, health, get rid of poverty, but we do it all through burning all of the fossil fuels on the planet. And we do it with no climate policy whatsoever. So when we run out of gas and oil, what we do is we liquefy the coal and we make that into oil and gas and burn it in all of our infrastructure and vehicles and transport. And when you hear the words, if we don't decarbonise, in a news article, or business as usual is still often associated with this, if you see those kinds of things headlining a story, then alarm bells should start ringing and do a bit of digging, because there's a really good chance they're talking about this pathway. And the important thing to remember is, really, business as usual is this changing pathway that we are on. That's SSP2. We have got climate policy. It's growing. You know, we know that's what's happening at the COP agreements, and countries are doing it domestically all the time. And we are decarbonising, and we'll touch on that really soon. And that's accelerating at a massive rate. So that's why it's important not to look at stories that say, yeah, if we don't decarbonise or if we don't cut emissions, because a lot of the time they're talking about this SSP5 pathway. Trying to find good information on it, I'd say stick to a very few places. Carbon Brief's really good. The Conversation's really good. It's all written by academics and they just do short reports on the work that they're doing. So that's an excellent resource. Both of them are free. And obviously there's journals as well. We've got those on our website. But if you can try and find good places to find information, then you'll be far better off and far more informed about the whole issue. So when it comes to uncertainty, it's a massive, massive issue. You know, climate, those IPCC reports are written by people from a massive array of backgrounds. So sociologists, microbiologists, mathematicians, physicists, biologists, chemists, psychologists. You know, it's an incredibly expansive area of research. And then you've got to ask the question, who has the best overview of this? You know, there's the physical and the chemical and the biological side of climate. And then there's also, you know, the impacts and how adaptable we are. And Hannah Ritchie from Our World in Data, she's at Oxford University. She's had a really good conversation with one of our former guests, Pete Irvine here, and on his podcast, which is really good, called Challenging Climate. There's a link to it here. But basically, she wrote an article in Wired a couple of years ago saying, stop telling our kids they're going to die from climate change. And the reason being is that, you know, we are really adaptable. We are on a different pathway to the one that we're seeing suggested by that SSP5, that, you know, business, that burning all of our fossil fuels pathway.
So get the other one, guys, as well on task. See who comes first.
Oh, sorry. Could you mute yourself, please? Could you mute your... Okay, that's cool. Yeah, so the important thing to remember is, you know, when you hear those really devastating stories, it's careful to just take them with a pinch of salt. Coming to the energy side of things, you know, this is really massive. RethinkX are a really interesting think tank, and they talk about like cost curves and learning curves, you know, changing how technology is rolled out within society. They talk about food, transport, data, and energy technology all being disrupted at the moment. And we can clearly see that data has completely disrupted how society runs. You know, we have elections, and everything from elections to, you know, what we watch on TV completely changed by the use of that information or data. Energy technology is definitely tipping, and we've moved into a new state now where renewables are going to be taking over, and transport as well. It's on the cusp of really taking off, as we'll see later. But even driverless vehicles seem like they're still pie in the sky ideas. But China's making real progress on this, and they already have vehicles that can take you through, you know, rush hour traffic without needing almost any intervention from a human being. But energy really is one of the biggest pieces, because the cost of it, as we're finding, underpins the cost of everything we do. You know, the energy crisis has taught us this one thing very, very clearly. And when we go through this transition that is partly caused by, the highest prices are partly caused by the fact that we're transitioning and we haven't done it fast enough. It's also really important. It really importantly underpins the cost of, well, as energy becomes cheaper, as we start to move more towards renewables, then it will start to open up a lot of things that we can do that we before couldn't afford to, because it was just too energetically expensive. And there's also some really interesting things that you have to bear in mind with, you know, with a system that doesn't need any fuel. You know, you don't have anything that needs to be mined, pumped, refined, shipped or burned, and it doesn't produce waste at all of those steps. And also we don't have energy price spikes anymore because everyone's producing their own. So what's certain about what we're hearing? Impacts are happening faster at lower temperatures than we thought. So ice sheets are moving faster. There's other parts of the climate system that are also seeing issues faster or earlier than we thought they would. So you've got AMOC there, which is the Gulf Stream, that's slowing earlier than we thought it would. Amazon rainforest is, it's under pressure, not just from climate, but from us deforesting it. And so that's exacerbating the problem. And we're seeing, the Amazon rainforest losing its resilience and potentially tipping towards a savanna earlier than we thought it would. There's overall 37 actual tipping points, and we've got to remember that between 1 and 2 degrees, 18 of those could go. I won't list them all here, but it's suffice to say that trying to keep warming as low as possible is really, really important. And we will go past 1.5. The Met Office thinks that it'll be the next 5 years that we'll tip over it, but we will see ourselves staying above 1.5 in the next decade or so. And there's some really interesting ways to find out what climate's doing in your local, in your country. So in the UK, you can see on Berkeley Earth, if you click on there, you'll find that we're actually at 1.5 already in the UK. France is at something like 2. Iraq, I think, is the worst country hit, and that's at 2.5 already. So it's different around the world compared to, depending on geographical location. One thing that is a bit of good news, though, is if we get to net zero by 2050, we could actually see cooling by the end of the century, because the Earth system pulls 50% of the CO2 out of the atmosphere that we currently emit already. And methane also is accounting for about 44% of warming, I think, at the moment. And methane is a massive, massive emitter. And if we stop producing that, then it dissipates in the atmosphere. It gets broken down by ozone in 12 years. So that's a huge component of warming that would be taken out of the system. And if we do take longer to get to net zero, then we could see that lag, that warming, carry on for much longer, and other tipping points potentially tip and make it harder for us to redress the balance in future. What about sixth mass extinction? Well, it looks like we are going through the sixth mass extinction. This is basically the IPCC for biodiversity, the IBPES, and we're going through a rate that's 100 to 1,000 times higher than the background rate normally. So it's very likely that we are in a mass extinction at the moment. And atmospheric CO2 is still building up in the atmosphere. It's really, really clear pattern, and we can see, both in the data here from Mauna Loa and in Hawaii, and also, the historical stuff. We can see just how rapid it's all rising. But because of something called land use change, the Global Carbon Project, they model emissions, and they've adjusted their modelling, and in 2021 they found that land use emissions are going down. So the way we manage forests or deforestation, and also the way we manage farmland, more of it's being relinquished back to the environment and being utilised in a more sustainable manner. So actually land use emissions are going down, and that means total emissions are actually they've been level roughly for the last 10 years. And this is something that not a lot of people really hear about, but it does show something really, really important, that we are turning the corner. And if you look at global emissions, you can see that as GDP goes up, as wealth goes up, then the production of CO2 goes up as well. But when you look at countries who are more developed and who are decarbonising, like the UK, you can see that now consumption-based emissions and emissions from production as well, they're going down, and GDP is still rising. We are seeing a signal from the pandemic here, and obviously we've got issues of our own with Brexit. But you can clearly see in the UK, in the United States, the pattern's the same. In Europe, the emissions are coming down as well, and their GDP is still going up. So then that takes us to how are we doing it? It's because of the energy transition. So the energy industry now invests, it's already starting to tip towards renewables. So 60% of all investment from the renewable energy industry is going to renewables over fossil fuels. And even if you look at big oil, BP is starting to decarbonise en masse. It's going from 2 gigawatts to 50 gigawatts in the next 10 years. Shell invests 30% of all its new investment in renewables. And we've got one of the biggest blockers that we actually have is actually grid connection. So in the United States, if they were able to connect everything on that is all the projects that they want to roll out in the United States that are waiting to be built, they could actually double the amount of electricity that they produce as a nation, just based on the stuff that's waiting in the pipeline. But it needs to be connected, and that's a big blocker. But if we can unblock that, the way things are moving as fast as they are at the moment, we would be fully electric globally by 2036. Now, obviously the grid connection thing is a huge issue, and it will slow us down massively, but it just goes to show how fast things are moving at the moment and how much progress is being made in spite of what we're often being told. Also now, renewable projects make up 95% of all the new energy that's going to be added in the next 5 years, basically. So, you know, when you hear about new coal-fired power stations being built in China or India, they make up a tiny percentage of all the energy that's actually being added. And if we look at things like in Ukraine, obviously that has had a really big impact, and it's really tragic that Russia are doing what they're doing. But it is driving policy. I'm going to blast through some of these things a bit quickly so we can get to the end. But basically, you know, it is stimulating more countries to do more. You know, the Green EU policies are basically representing 1.4% of GDP now. That's in the kind of ballpark that we want globally to be invested to get us through, you know, the climate and biodiversity crisis. You know, they're going through gas boilers being banned. They're running out heat pumps much faster now. So you're going to see a doubling in the use of heat pumps in Europe in the next 2.5 years, like every 2.5 years. So that's like going up at a really rapid rate. You know, we're going to be linking ourselves to Morocco by a massive X-Links cable that's going to, you know, help back up our renewable energy grid. And we've got nuclear power stations being kept open longer than they were projected to, or they were going to be shut earlier. But these are all things that are happening in response to trying to keep our emissions down. So California, they were going to decommission Diablo Canyon. In Belgium, they were going to decommission some of their power stations early, and they're keeping them open now. So they're recognising the utility of, you know, low carbon energy more now. And if you look at China, a lot of people like to be down on China, but really China is leading the world. In the next 5 years, or 4 years now, they're going to add 33 UK's worth of energy in the form of renewables to their grid. And they've already installed 70% of all the wind on the planet. And the reason for these kinds of things, or they're driving this as well, to be fair, is if we look here, these lines represent how fast people like the International Energy Agency and people who do models like climate and integrated assessment models, they're called. They're the ones that the IPCC uses for projecting like future scenarios. But these guys have been predicting at every turn that the cost of energy production in these renewable sectors was going to fall much more slowly than it actually has done. And they also got wrong the floor price as well. So they thought that it would never get cheaper than certain levels, but the cost keeps falling. And this is really changing the situation that we're in with renewable energy. So there was a paper that came out from Oxford University recently, and it looked at all of this, and they really, really tried to give the benefit of the doubt to renewables. Not all the assumptions they made were to basically make it so that renewables had the toughest job ever, and when they were just running their projections, what they found was that basically in every sector that's necessary, so wind and solar and batteries, and these are electrolyzers to make hydrogen, all of these costs are set to come down, and they're always coming down continually faster than have been projected. So, so look. Oh yeah. So as an example, so since 1980s, you know, solar is now 300 times cheaper than it was when it was in its first rolled out, and so it's falling a lot faster than we thought it would do. And you can look at what's happening on the national grid and stuff. There's a really great link here to National Grid Live, and if you look at what's happening, like that's our generation roughly today, you can see that in the day it changes, more wind depending on obviously the wind, but also solar kicks in as well. So there's great ways to look at all of this kind of stuff. But one of the reasons that it's changing so quickly is because the technology is becoming more efficient. So wind turbines are getting even bigger. And some of these in China, for example, this one's got 280-meter diameter on it. These are bigger than the ones that we've got rolled out of the Hornsea 3 project that's happening in the North Sea. That's going to be powering 2 million homes, and each single turbine will power 8,500 homes. And when we think about and there are actually plans to build offshore wind turbines in the United States that will power double that many from a single turbine. So wind is really coming on. And the impact of wind as well, you know, we've got to remember that it does have an environmental impact, but I know that people, you know, Natural England, for example, they do a lot of permitting work with, you know, these companies to make sure that they're placed in the best possible place and they have as little environmental impact as possible. And they're being designed in such a way that, you know, nature doesn't get, well, like avian animals. So, you know, birds and bats don't have impacts with them as much as possible. And Mark Maslin likes to share this on Twitter a lot. But, you know, cats do a lot more damage than wind farms do at the moment. Obviously, that will change as they increase in number, but you know, it'll be offset by the fact that we're going to be planning and putting them in the right place and designing them in a way that makes it so that they, you know, don't have as much of an impact. So what about positive tipping points? Well, you know, there's this thing called the energy trilemma. And so security, affordability and sustainability, they're key things you need for an energy system to work and have a future. And we've got that with renewables. It does all of those kinds of things. Every country can have a renewable capacity of its own. It's cheaper to now wind and solar than it is for fossil fuels. And obviously it's sustainable. And it also meets the needs that we have today with climate change, because morally it's better. It's just better for people to have cleaner air and electricity that's cheaper. Logistically it's better because we need it. We've got no choice but to transition off fossil fuels because they're going to run out and they're destroying the planet. And then economically, having something which just doesn't need any fuel, it's hard. People often don't think about that, but it is a massive game changer. It just makes them so much cheaper, and you don't have to worry about price shocks for global fuel supply like we're seeing at the moment. And again, just going back to this, 95% of the increase in global energy supply is going to come through renewables in the next 5 years. So we are seeing a really disruptive change. Fossil fuels are still the king. It's like 80% of our energy comes from them, but that's not going to last for much longer. There is some interesting work that Exeter University and work that events that are actually going to be on this week that you can watch. We've got them linked on our events page. But that's about positive tipping points in society, and there is a good point to. There's good reason to think that we've actually gone past that point now. So this is a survey done on 1.5 million people by Oxford University and the United Nations, and if you look at the public awareness or public belief that climate change is an emergency, you can see that out of all the countries that they surveyed, the United Kingdom comes out top. 81% of people think that climate is an emergency, and of these people who think it's an emergency, almost 60% think that we should be doing everything necessary to address it. Now, a lot of people think that most people don't really worry about climate change, but the reality is there's a lot more room to discuss this with people than we actually often think. When you look at how things are changing as well in the electric vehicle market, it's quite interesting to see just how quickly these kind of opinions are helping to drive the consumption of more sustainable goods. So we can see, China's obviously maxing out on the electric vehicle front, and it's changing in Europe and all the other countries, and United States and others. When you look at the UK, ours is going really fast as well, and we're expecting 20% of all new car registrations, I think, in next year to be electric. So I won't go into this too much, but basically they're always better. Electric vehicles are always better. They use more minerals here. You can see it's harder to make an electric car, but actually they produce less CO2. And also the other thing is, electric cars, they're much more recyclable. So, the battery inside cars and stuff, lithium-ion batteries, it's only one of the types of batteries that's projected to be used in cars, but that's incredibly recyclable. And the industry is chomping at the bit to get hold of those lithium-ion batteries. But also, Tesla is looking at building the first 1 million mile battery. They've already built a car that has done 1 million miles, and it didn't need the drivetrain, where the engine drives the wheels. That lasted for 1 million miles. So they're really looking at creating a really different thing to an internal combustion engine car. And then there's their ability to back up the grid. When you plug them in, they can iron out the peaks and troughs in energy production and demand. There's a huge potential there, and even with driverless vehicles, things could change massively in the future. And also, shipping will change. 40% of all the weight of maritime trade is done for fossil fuels like gas, liquefied natural gas, coal and oil being moved around the world, and we won't need to do that in future. So what about the public sector on net zero? Well, you all know I'm sure what net zero is. You reduce your emissions as much as possible and then you offset the rest. And the government's made their legally binding commitment to reduce emissions by 78% by 2035 on 1990 levels. That's been declared unlawful, unfortunately, because our efforts have, because we just don't have a plan to get us there. But before that, the Environment Agency was the first public sector organisation, I think, in the world to go for net zero. This is a few years ago now. But since that's happened, obviously the government's been stepping up, and Crown Commercial Services, who source everything for the government, or most things, they're looking into all of their emissions, scope 1, 2 and 3, and they're doing some really great work on that. We've got volunteers from them with the Collective for Climate Action. HM Revenue and Customs now they're running events where public sector organisations can talk about and discuss like best practice in reaching their net zero targets. And the NHS is a real hotbed for loads of climate action, and there's loads of really well-resourced groups within the NHS, all looking at anything from plastics to the sustainability of anesthesiology, the technologies used for that, and the gases. What about other stuff going on? Well, we've got the Cross Government Climate Hub and the Collective for Climate Action, and we host it, but it's for all communities of anyone in the public sector. We've got 250 councils on there and 100 public bodies in addition to that as well. Civil Service Environment Networks on there. We've got Greener NHS represented there. UK School Sustainability Network, we're connected with them, but they're not on the platform, but we do, I think we were found through them for this event. And the LGA is now sending, or they have been for a couple of years now, sending climate officers to us, to our platform to share best practice. And UK RI are now, offering some funding for us to help facilitate that work with councillors. And we've got non-profit organisations on there as well who are basically working to, help decarbonise the public sector. And through the size of our network now, we're also engaging with the British Academy, who are writing policy for policy recommendations on net zero for government. And also thinking about the policy side of things, the other thing to remember as well is that policy means money and stability. And if you don't know about the Inflation Reduction Act already, this chap here, basically, Joe Manchin almost torpedoed what is thought to be one of the most pivotal bits of climate legislation on the planet, because I won't go into it too much detail, but basically it brings the United States to the table on climate, and that's going to drive ambition by all countries who are involved in this space. And so it's a massive win to have them on board, and it's something that it can't be dismantled by a Republican government coming in, because it's been enshrined in law and that money's going to get spent whether they like it or not. Also, some more research done by the Energy and Climate Intelligence Unit was saying that the world's largest emitting countries and trading blocs, so like the EU, the United States, India, China, it looks like they're going to be meeting their emissions targets ahead of schedule at the current rate. So then it takes us to where we're actually going to go. These guys, the Carbon Action Tracker, they do some great work on projecting where we are, looking at policies and action. And at the moment, we're in the ballpark of like 2.7, degrees, which is way better than we thought we were going to be at this point, based on the amount of inaction that's been happening for the last few decades. Worst case 3.4, best case 2.2 degrees. If we meet all of our pledges, then it's 2 degrees, possibly 2.5. And as we said before, like, we are starting to decarbonise faster, largely because of the rate of cheapening of renewable energy. But we don't. Somewhere between these projections is where we're kind of aiming at the moment, or looking. But the thing is to still remember, there's still unknowns in the climate system. There's tipping points that we don't fully model. So there's still surprises left in store, and we should take these too with a pinch of salt. But it's going to be hard to project how fast the impacts will come, and also how fast we'll respond. So that really is the key. How fast we respond to all of this is really going to drive where we get to. So thinking about what we need to address most, well, we've got biodiversity, energy and land use, education and money. These are all really big parts of it, and money's become a really big part of the COP27 discussions, and arguably it's really important that we've gone down the route of trying to get more money to developing nations. Energy and land use, that's starting to take on a world of its own, because it's got these economic drivers that are pushing it forward now. So it makes no sense for anyone to start really going for fossil fuel infrastructure on a massive scale anymore, because renewables are just better. But we definitely need to look more at conservation. We still don't understand enough about the biosphere to really start taking massive risks with it, which we continue to do. The oceans are massively degraded. The UK is one of the most degraded land masses on the planet. We need to really think about regenerating the landscapes and the oceans that we manage. Also, getting getting climate into education is massively important. Getting people on board at a young age and showing them not just what climate is doing, but also how to address climate change. It's hugely important to show them that there is possibilities for working constructively, really making a difference, communicating on it, thinking about it. There's all sorts of ways that we can make differences on climate change. And if we understand that from a young age, then we've got a far better chance of society, voting for these kinds of policies and taking, useful action across society in response to climate and biodiversity decline. I won't focus on that too much. But one of the problems we have with regards to money is there's far too little investment. This is out of COP27 really. In lending and aid. Al Gore did a great speech talking about the private sector. It provides 96% of renewable investment in the United States, but only 14% across Africa. So most of it in Africa comes from the public sector, and that's a real drain on government. But in the States, it's massively from the private sector, because they know they can make money out of it. But in Africa as well, they pay 7 times more interest on loans. So borrowing money to do the job is really, really difficult in Africa compared to Western countries. And so finance has to be done in a better way, and it needs to get to the countries that will struggle most to pay it back. I know that's going to be a difficult thing for the finance industry to do, but you know, everyone needs money to do this, to do the research and innovation, the adaptation, the mitigation, and thinking about how money is a really important part of all of this. If you look at the Clean Air Task Force, they've been independently rated as a charity on climate change by Just Giving campaign, or Founders Pledge now. And if you donate $1 to them, they will prevent the emissions of 1 ton of CO2 being released into the atmosphere, or 1 ton of CO2 equivalent. And so when you think about how hard it is to decarbonize your 7 to 10 ton ton of carbon dioxide lifestyle a year, and think how much money you'd have to spend to, you know, get heat pumps in your house, solar, stop flying, you know, get an electric car, and you think about there are so many low-hanging fruit out there. Mostly what the Clean Air Task Force do with their low-hanging fruit is going for preventing the leaking of methane from oil and gas infrastructure. But if you want to raise money for a charity, it's a good idea to raise money for a charity that you're passionate about, and then raise awareness of these other ones, because charities like this can really have a really massive impact in a way that's kind of not tangible to us. But you know, that's the thing about climate change. It's not tangible to us as individuals, but you know, nature is a perfect accountant. So it doesn't matter where the impact is had, it's just about how big that impact is. In terms of researching the solution, adaptation is now starting to really take shape in city planning, you know, greening cities, shading, reflecting sunlight back into space, and connecting, you know, infrastructure, transport infrastructure to make it more efficient. The conversation on migration really needs to be had. There's a great link here to a talk that Paul Behrens did. Basically, we're seeing the constraints of not having massive immigration come to us now, and in future there's going to be people who won't be able to live where they currently live, and the solution for that is that, you know, our population's in decline, so we're going to need people to do stuff for us and to live in the buildings that we no longer inhabit, and, you know, use the schools that we no longer use. So migration and talking about the benefits and trying to be more welcoming of people coming to this country and understanding what they provide us is really important conversation to start having. And the research area in that is starting to really gain momentum. But carbon capture is really important as well. We are going to go past 1.5, but we need to start thinking about ways to capture that carbon. The Climate Crisis Advisory Group is a really amazing organisation attached to Cambridge University, and they basically look at all projects that capture more than 1 gigaton of carbon dioxide a year. We need to capture in excess of 40 because that's what we produce, but there's other ideas like refreezing the Arctic from the Cambridge Centre of Climate Repair. But this project that Mar Fernandez-Mendez is doing in growing seaweed, that alone will capture 1 gigaton of carbon dioxide a year if it's rolled out to its full capacity. So the research in these areas is really gaining momentum. Also, there's some great solutions about desalination. Water is going to be one of the biggest, water scarcity is going to be one of the biggest problems we face with, changing climate, and also just the fact that we're using up water. That in itself is a really massive problem. And then that takes us on to kind of geoengineering. That's something that I'll look at on the next slide, but this is just like the basic overview of what the CCAG looks at. Removing emissions, reducing emissions, and repairing the environment, and slowing down the change of climate change overall. Now, many of you might know what geoengineering is, but basic idea is to slow the warming. Sorry, I'm picking my nose. I'm rubbing my nose a lot. But the geoengineering is slowing down the warming. It's basically reflecting sun back into space. And if I'm completely honest, it looks like this is going to be so cheap to do relatively to the impacts of climate change that it seems very unlikely that we're not going to do it. It's reasonably well understood, but more research needs to be done. But what this will do is it will basically, as the world warms, we will probably be using this to knock, 1.5 degrees of warming off what the climate projections are telling us. And that will buy us more time and take some of the pressure off the natural environment and stuff while we start remediating things. I won't talk about inequality, that's still a massive problem. But one of the things that's really interesting to talk about is protests. And, we often hear that, people get annoyed with protesters, but research is coming out now where even when we attempt to frame protesters as real kooks and, extremists, people don't stop supporting the causes. They just question and criticize their methods of drumming up support for that. So if we look at after Extinction Rebellion's protest in 2019, there was a massive uptick in talk about the environment. We can see Insulate Britain here, massively raised the issue of insulating houses. And very timely it was too. But basically, the other thing it does is the radicals free up more space for people with, more to make what seemed like more radical ideas 10 years ago. They become much more conservative, and more people are more welcoming of them in a wider part of society. So it's really useful in that way as well, and it changes the conversation. So protests, they do a really useful job, and it's just so if anyone does do that kind of thing, I'm not advocating that we do, but it does make a difference. And we're at a point where every fraction of a degree really does matter. We are going to pass tipping points, and there are climate tipping points, but there are also social ones as well, going in the other direction. The more we slow climate, the more time we buy to adapt to it, to conserve ecosystems, and mitigate climate change, and buy us even more time on top of that. So the change is inevitable, but we can deal with it more effectively the more time we give ourselves. And that's why energy and land use is doing its thing already, and it's got economic incentives behind it. We need more money to be flowing into these areas through policy and private investment. Biodiversity, that really needs some weight behind it. And obviously education as well. There's some great organisations working on building that into schools. So the future will be different. It's going to be harder. We're going to be materially poorer because it's, for the moment while we transition, it's going to be harder to produce goods because it's going to be more expensive, because energy is more expensive. But how much do we really need? The other thing, to be content with our lives in terms of consumption, and also information and education, it will be available to far more people now through the cheapening of devices and the availability of data and information through the internet. And the other thing to remember is what we're doing now is working. We are turning this ship around. So, protesters, advocates, volunteers, people working as professionals, people just talking about this kind of thing. It's all changing the conversation and making it real that we have actually finally started this journey. And since I got my degree, I was waiting for a long time to really see any tangible change. And now we are finally seeing it. And also the really big thing to remember is that we're really adaptable. So, in terms of absolute deaths from natural disasters over the last century, they've actually fallen massively, even in spite of the fact that population has increased massively by almost 7 times in the last century. The number of deaths, because we're more adaptive to these events, has actually fallen really, really sharply. So thinking about what to do about it, I think one of the things that is kind of an injustice in some ways is that we talk about STEM subjects being the answer, and they're great for economic development and everything. But it's not just about people working in STEM subjects, although that is very important. We need to do more than just understand it. We need to act on this as well. So we need to rebuild our energy system and capture carbon and regenerate the environment. And we'll need everyone to help us out with this, like communicating, people doing heating engineers. We're going to need 30,000 of them in the next 5 years. People working on the land, farmers, landscapers. We need regulators to prevent environmental damage, people to organise events and groups, teachers to help children and pupils to understand these kinds of things, people doing conservation, and politicians and policy. We're going to need all of these things, and they're not just people with scientific backgrounds to do those jobs. And also, if you're not working in it, you can volunteer in it. I do this on a volunteer basis. Loads of it's outside of my work, most of it really. And also volunteers, so advocates. But you can see all of these groups here, most of them have been started by NHS, Carbon Literacy Project, UKSSN, Climate Emergency UK. They've been started by volunteers, and now they're kind of bona fide operations that have fully employed members or employees. But talk about it. Learn how to communicate on climate change. Is a really great video from the Climate Outreach to help you do that. Look for the most impactful solutions, have a look at our resources, find actions that are meaningful to you, to other people, share them with people, try and have the greatest impact, and help others who are already working on it as well. So charities, banking, we've got details of all these things on our website. Getting people to change their pensions and investments. You can often make more money in what they're called ESG investments now than ones that are regular investments. And also, volunteer groups, helping them out. There's so much work needs to be done that's not being done. It makes a huge difference when you do it with other people. And you can also prepare for the big decisions in your life, like saving up for government subsidies when they come for heat pumps and things like that, and solar panels, that kind of thing on your house. And think about your career. You know, if people are just starting out, there's a really great website called 80,000 Hours, and that helps people to think about having the most impactful career, you know, to help humanity, basically. And they've got loads and loads of resources on there. It's linked to Oxford University, I think. You know, think about, do you need it? Learn about climate, think about the solutions, talk about it, and if nothing else, join a group. You know, taking action on climate, just starting to do stuff, it helps break that barrier to you doing more. You know, you don't have to be protesting. There's loads of community groups to get involved with, and there's loads of ways to learn more about the climate and biodiversity crisis, and to actually act on it. And, you know, let people know about what's actually really happening as well. You know, we are making progress, and that's a really important thing to remember.